we're given that the general term of the series, let's denote it by uk, is equal to 2k plus 1 divided by k square times k plus 1 whole square. Now note that 1 upon k square minus 1 upon k plus 1 whole square, which is equal to k plus 1 whole square minus k square divided by k square times k plus 1 whole square, which in turn is equal to k square plus 2k plus 1 minus k square divided by k square times k plus 1 whole square, is equal to 2k plus 1 divided by k square times k plus 1 whole square. And note that this is the same as uk. Therefore, the general term uk can be written as 1 upon k square minus 1 upon k plus 1 whole square. Now put k is equal to 1, we get the value of the first term u1 is equal to 1 upon 1 square minus 1 upon 2 square. Put k is equal to 2, the second term u2 is equal to 1 upon 2 square minus 1 upon 3 square. Put k is equal to 3, u3 is equal to 1 upon 3 square minus 1 upon 4 square, and so on and so forth. Put k is equal to n minus 1, un minus 1 is equal to 1 upon n minus 1 whole square minus 1 upon n square. And finally, putting k is equal to n, the value of the nth term un is equal to 1 upon n square minus 1 upon n plus 1 whole square. Now adding all of these expressions on the left hand side, we get the sum of the n terms of the series. Let's denote it by Sn. And on the right hand side, 1 upon 2 square in the first equation cancels with 1 upon 2 square in the second equation. Similarly, 1 upon 3 square cancels with the term in the next row, and so on and so forth. And we're left with only two terms on the right hand side, and so the value of the right hand side is equal to 1 minus 1 upon n plus 1 whole square. And this is the sum of the first n terms of the given series. Now to obtain the sum to infinity, let's denote it by S infinity. We take the limit of Sn as n tends to infinity, which is equal to the limit of 1 minus 1 upon n plus 1 whole square as n tends to infinity. Now, as n tends to infinity, n plus 1 whole square also tends to infinity, and therefore 1 upon n plus 1 whole square tends to 0. And therefore the sum to infinity is equal to 1, which is the required answer.